Hello everybody. In this video, we are going to talk about the polar coordinate system. First of all, we begin with a reminder about the usual rectangular coordinate system. The horizontal line is called x-axis in the figure. The vertical line is the y-axis, and the intersection of the x-axis and the y-axis will be the origin. And an ordered pair is used to represent the position of a point. And we usually count the horizontal distance as the first coordinate. The name is called x coordinate. And the vertical distance is regarded as the y coordinate. And we know that the coordinates of the origin should be 0, 0 in this usual Cartesian coordinate system. Instead of the usual rectangular coordinate system or Cartesian coordinate system, we have another kind of coordinate system which is called polar coordinate system. Now we take a point O on the plane and call this point pole. Draw a horizontal line from O towards right, and we mark this line X, and it is called polar axis, OX. And starting from OX, we give an angle, measure in anti-clockwise direction, and the angle is theta, and this is called a polar angle. Now the angles arrive at an arm OP. And suppose the length of OP is R, then R is the radius. The length of OP is the radius vector of P, as shown in the figure. And we say the polar coordinate of the point P is denoted by R, theta. And our usual practice, R must be greater than or equal to 0, and theta lies between 0 degree to 360, including 0 degree but excluding 360 degree. Let's take a look at the example. We have a point A here. We can see that the distance from point A to the pole O here is 1, 2, 3, and 4. 4 units. So the radius vector is 4, and the angle measured from the horizontal line, that is the polar axis, to the radius vector here, measured in anti-clockwise direction, is of 60 degree. You can see here 60 degree. So the polar angle is 60 degree. And we say the polar coordinates of A are 60 degrees. Okay, similarly, for B, the polar coordinates should be 180 degrees, measured from the polar axis, 180 degrees. The polar coordinate of the point C here is measure the distance from O to this line is 5. And the angle measured from the polar axis to this point is here, is this angle, 270 degrees. So the polar coordinates of C are 5, 270 degrees. Now we are going to consider the relation between the polar coordinate and rectangular coordinates. And we are going to establish formula for conversion between these two kinds of coordinates. Suppose we is a point in the plane. How can we convert its rectangular coordinate to polar coordinate, or vice versa? We have the following theorem, which can help us to perform conversion. Okay, you can take a look at the theorem one first. Suppose the rectangular coordinate of P are xy, and the polar coordinate of P are r theta. and we know that r is greater than or equal to 0, and theta lies between 0 degree to 360 degree. Then we have these two facts. First, x must be r cosine theta, and y must be r sine theta, the first formula. Second, in the other way around, using property of trigonometric identities, we know that r must be square root x squared plus y squared, and we know that tangent theta must be y over x. Alright, how can we use this theorem to convert rectangular coordinates to polar coordinates or vice versa? We first consider the case if we want to convert polar coordinate of a point to rectangular coordinate. Now, suppose I know the polar coordinate of a point P. It is the coordinates are r, theta. And we want to find the rectangular coordinate of the point P. So we have the following steps. First, write down the sentence. Let xy be the polar coordinates of P. Use the formula x equals r cosine theta to find x, and use the formula y equals r sine theta to find y. Then write down the rectangular coordinates as the final answer. Okay, steps. Suppose you want to convert the polar coordinates 3, 210 degrees to rectangular coordinates. Let's take a look at the steps. Let xy be the polar coordinates of the point P. Then x must be r is 3, and theta is 210 degrees. Theta is 210 degrees. So x must be r cosine theta. Cosine 210 degrees, which is a special angle. It should be negative root 3 over 2, multiplying negative 3 root 3 over 2. Now, for y coordinates, we should use the formula r sine theta. And we know that sine 210 degree will be negative 1 over 2. Multiplying, we have negative 3 over 2. We know that once we know the value of x and y, we can write down the rectangular coordinates of the point P. It should be negative 3 root 3 over 2, negative 3 over 2. Then we have obtained the rectangular coordinate of the point P. Now, we are going to consider the procedure of converting rectangular coordinates to polar coordinates. This part may be a little bit more difficult than the previous one. Suppose we know that P is a point with rectangular coordinate xy, and we want to find the polar coordinate r theta of P. Now, we have several steps to complete. First, draw a rough figure to locate the point P in the rectangular coordinate plane, and then decide which quadrant P lies in. Write down the sentence that r theta be the polar coordinate of P, and use the formula r equals square root x squared plus y squared to find r. You can find r immediately. Then use the formula tangent theta equals y over x to find the value of tangent theta. But note that we can only just find tangent theta. And then the most difficult part is to design the value of theta. Case 1, if tangent theta greater than 0 and P lies in first quadrant from the figure here in step 2, then you can press shift tangent in your calculator of the value y over x obtained in step 5. Then theta will be this angle. Second case, if tangent theta is positive and theta lies in third quadrant, press shift tangent and then add 180 degrees to the answer shown in the calculator. Then you will get the theta. The third case, if tangent theta is less than 0 and theta lies in the second quadrant, then omit the minus sign, just calculate y over x and omit the minus sign, passing shift tangent, you'll get an angle which lies between 0 to 90 degrees. Then use 180 degrees minus the angle obtained from the calculator. I stress that you should calculate y over x and then omit the minus sign before pressing shift tangent. Then you will get the angle theta. The last case, if tangent theta is less than 0 and P lies in the fourth quadrant, then calculate y over x, omit the minus sign, and pressing shift tangent from your calculator. You will get an angle. Take 360 degrees minus this angle. You'll get the value of theta. Now, after step 6, you know the value of theta, and step 4, you know the value of r. Write down the polar coordinates r theta as the final answer. Okay, example. I know the point P is rectangular coordinates are 3, -4. I want to find its polar coordinates. Okay, draw a rough figure. 3, -4. It looks like this, the position of P. So, P lies in the fourth quadrant. Bear in mind, fourth quadrant. We know that P lies in fourth quadrant now. We let r theta to be the polar coordinates of P. Then, r is given by square root 3 squared plus -4 squared. Simplifying, you have 5. We know that r is 5. And then, how to find the angle theta, polar angle theta? We divide y by x, -4 over 3. Now, 4 over 3, omit the minus sign, you have 4 over 3, and then passing shift tangent, you have 53.130 so and so degree, because the point lies in fourth quadrant. According to the rule here, fourth quadrant, 360 minus shift tangent of the value of change. So 360 minus 33.13 so and so, you have 306.869 degrees. If we correct the answer to 3 significant figures, the polar coordinates of the point P should be 5, 307 degrees. And that is the final answer. Okay, and these are some important notes about handling problem in HKDSC about polar coordinates. First, always try to draw a rough figure before solving a problem if the figure is not given to you. Second, try to find the sum or differences of polar angle of the given points. Usually, you may get 90 degrees or 180 degrees, etc. in most of the questions appear in section A. Now, if you are required to find length area of certain object, always seek for right angle in the figure, and then use Pythagoras theorem or trigonometric ratio. Now, the last point, if you have no idea of how to solve a problem involving polar coordinates, you may always use the method I have introduced before to convert all the polar coordinates to rectangular coordinates. Then apply the usual technique that you have learned in junior form about rectangular coordinate geometry. Then certainly you can solve the problem, but the disadvantage of this technique is your calculation will be complicated and some marks will be deducted, in DS exam because of not giving exact value by using your calculator. Now let us consider some past paper questions which are related to polar coordinates. Example 1, which comes from 2012 DSC practice paper. Paper 1. Now, in a polar coordinate system, the polar coordinates of point A, B, C are 13, 157 degree, 4, 247 degree, and 15, 337 degree. Let O be the pole. The question asks you, are AOC collinear? Explain your answer. And then you are asked to find the area of triangle ABC. No figure is given to you. So we should first draw a rough figure. This is the pole O and the polar axis OX here. Polar axis OX here. Now, we first mark the point A, 13, 157 degree is about here in the second quadrant. B, the radius vector is 4, 247 degree about here. And C, radius vector 15, polar angle about 337 degrees about here, fourth quadrant. Now, how to show that where AOC is collinear? Check whether the angle, say for example AOC, is of 180 degrees. How to find AOC? We know this angle is from XOC will be 157 and XOC will be 337. XOA 157, XOC 337. So use the larger one minus the smaller one. You will have 180 degrees. Since AOC is of 180 degrees, therefore AOC are collinear. Part B. We try to show that AC is perpendicular to OB. AC here, the line AC is perpendicular to OB. How to show? Just check whether angle AOB, this angle, is of 90 degree or not. Is it of 90 degree or not? All right. Now, angle AOB, 247 degree minus 157 degree, which is, luckily, which is 90 degree. So, go back to our question. If we want to find the area of triangle ABC, according to the question, this triangle, ABC, then we calculate the base times height divided by 2. Why OB is the height? Because we know that it is of 90 degrees. OB is perpendicular to AC. So the area is given by OB times AC divided by 2. From the figure, OA is 13 and OC is 15. So AC is totally 13 plus 18, which is 28. OB is of 4. So 13 plus 15 times 4 divided by 2. And the final area is 196 square units. Second example, which comes from 2012 DSC paper 2, an MC question. Now, the rectangular coordinate of point P are -3, -3 root 3. P is rotate anti-clockwise about the origin, full 90 degrees. Then find the polar coordinate of its image. All right. We should draw a rough figure first. This is point P, -3 root 3, which lies in the third quadrant. And it is rotate about the origin in anti-clockwise direction by 90 degrees. So we let P prime be the image of P after rotation, and let R theta be the polar coordinate of P prime. And we first find the polar coordinate of P prime. Recall that you have learned in P1, Form 1. The polar coordinate of point P should be negative y comma x. So negative root 3 root 3 comma negative 3, which is 3 root 3 negative 3, the rectangular coordinate of the image of P. So we have taking the convert this one to polar coordinate, then we can solve the problem. The radius vector should be x squared plus y squared and then take square root. You will have root 36, which is 6. And remember the formula, convert rectangular to polar. Tangent theta will be y over x, negative 3 divided by 3 root 3, which gives you negative 1 over root 3. So, forget about the minus sign. Passing shift tangent 1 over root 3, you have 30 degrees. And don't forget, here is in the fourth quadrant. According to the rule we have introduced, the angle must be 360 degrees minus the value obtained by passing shift tangent in your calculator, which is 30 degrees. So theta will be 360 degrees minus 30 degrees, which is 330 degrees. Combining the value of r, which is 6, and the value of theta, which is 330 degrees, the polar coordinate of the point P prime must be 6, 330 degrees at the end. The third example, which is a past fair question, 2013 DSC, question 6 in paper 1. Now, in a polar coordinate system, O is a pole. The polar coordinates of A and B are 26, 10 degrees, and 26, 130 degrees, respectively. Let L be the axis of reflectional symmetry of triangle OAB. Now, the first part, you are required to describe the geometric relation between the line L and angle AOB. Second, part B, find the polar coordinates of the point of intersection of L and AB. Note that in this question, the figure is not given to you. So, the first step is to draw a figure by yourself. We start with O and the polar axis, OX. Now, 10 degrees, 26, 10 degrees, A is here. The length is 26. This is 10 of 10 degrees. Next, for point B, again, 26, the radius vector. The angle measured from OX in anti-clockwise direction, 130 degrees. And the figure looks like this. Now, a line L is you have triangle OAB in the figure. Line L is the line of symmetry, reflectional symmetry of triangle OAB. So this is L, the axis of reflectional symmetry. And the intersection of the point, the line AB and L, this point will be P. The polar coordinate is r theta. I'm going to find r theta. Part A, describe the geometric relationship between L and angle AOB. You can see from the property of this is a isosceles triangle. Both of OA and OB are of length 26, right? 26 here. Therefore, OAB is actually an isosceles triangle. Therefore, OAB is an isosceles triangle, and therefore, OL must be the angle bisector of angle AOB. Not too difficult to visualize it. Now, I want to find the polar coordinates of P, that is the point of intersection of L and AB. We can see that let PR theta be the point of intersection of the line L and AB. Now we can see that angle AOB is of 130 minus 10, which is 120. This angle shaded in red, is 120 only. Once we know that angle AOB is of 120 degrees, well, we want to find the polar angle. The polar angle of the point B should be measured from OX to this line L, which is given by 10 degrees plus half of the red angle here. And therefore, we know that theta is 10 plus 120 divided by 2, which is 70 degrees. And the remaining part, we should find R. We know theta, but we need to find R. That is the distance between O and P. And note that from trigonometry and plane geometry, the fact this must be a right angle, and OA is 26, and the red angle is 60. So OP can be easily obtained from trigonometry. OP must be 26 cosine 60 degrees. And cosine 60 degrees, a special angle, which is 1/2. Simplifying, R must be 30. Therefore, the polar coordinates of P should be 13, 70 degrees. And we have solved the whole problem then. Example 4. Again, another question from DSE 2016, paper 1, question 7. In the polar coordinate system, O is the pole. And the polar coordinates of A and B are 12, 75 degrees and 12, 135 degrees. Now find angle AOB. And then find the parameter of triangle AOB. And finally, write down the number of folds of rotational symmetry of triangle AOB. Again, we need to draw the figure first. O is the pole, OX is the polar axis. A, polar coordinates, 12, 75 degrees. 12, 75 degrees. And B, 12, 135 degrees. Part A, very simple and quick application. Angle AOB is given by, from the figure, 135 minus 75, which is of 60 degrees. Okay, 60 degrees. Now, you can see from the figure that this is 12, this is 12. OA is 12 and OB is 12 also. Therefore, again, triangle OAB is an isosceles triangle with OA equals OB. So their base angles must be the same. Angle OAB must be the same as angle OBA. And therefore, because this angle we have done in part A, which is 60, which is of 60 degrees. 60 degrees. Therefore, the two base angle must be 60 degrees also. 180 minus 60 divided by 2. And you can see that it is not only an isosceles triangle, but all the three angles are the same. All of these angles, all of the internal angles are 60. Therefore, triangle AOB is actually an equilateral, not only an isosceles, but equilateral triangle. Therefore, AO, BO, and CO, AB are all equal to 12, and the parameter can be obtained easily. It must be 36 units. Part C. What is the order of rotational symmetry? because it is an equilateral triangle, the order of rotational symmetry is 3. This is a simple fact that you have learned from Form 1. Example 5, 2017 DSC, Paper 2, MC question. The polar coordinates of PQR are 3 160 degrees, 4 280 degrees, and 6 340 degrees respectively. Find the perpendicular distance from Q to PR. Again, no figure is given to you. Draw a rough figure by yourself. Here, O is the pole, OX is the polar axis. First mark down P, 3 160 degrees about here. And then Q, 4 280 degrees about here. R is given by 6 340 degrees here. I want to find the distance, perpendicular distance from Q to PR. Right, this PR is actually, POR is actually a straight line. You should check because 340 minus 160 is 180. So POR is a straight line. It is not, POR is not a triangle. Instead, it is a straight line. So we net the foot of perpendicular of Q onto the line POR to be S. In triangle, SOQ here, OQ is 4. It is no doubt check OQ is 4. And the red angle here is what? If we can find the red angle here, then we can use trickle to find QS. SOQ, the angle, should be this angle, 340 minus this angle, 280. So SOQ is given by 60 degrees. 340 minus 280, which is 60. Now, the required distance can be calculated easily. 4 cosine this angle, 60. And cosine 60 degrees is special angle 1/2. Multiplying, the result will be 2 units. Therefore, QS is 2 units, and the required distance from Q to PR is hence 2 units.